Day 475 of doing a LeetCode problem every day. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1504, count submatrices with all ones. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an m by n binary matrix mat, return the number of submatrices that have all ones. All right, y'all, so that may seem a little bit confusing. So let's take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have our input mat equals a 2D array of integers, first array being 101, second array 110, third array 110. So first let's go over what these arrays mean right inside the initial array. Each one of these arrays just represents a different row. So this is the top row, this is the middle row, and this is the bottom row, all of our matrix. The output is 13. Explanation says there are 6 rectangles of side 1 by 1. So the side 1 by 1 just means there's just one square, right? So there's 6 rectangles or squares that have a 1, and that's just the squares or the rectangles that have a single 1. So this is 1, 2, 3, 4, 5, 6. There's 6 in total. Then there are 2 rectangles that have sides 1 by 2, right? So this right here has a 1 by 2. This square and this square or rectangle, these 2 rectangles form this rectangle right here. That's a 1 by 2 rectangle. Then it's another 1 by 2 rectangle right directly underneath it right here. Boom. So there's 2 of those, so we add that to our count. Right now we're at 6 plus 2. Boom. Then there are 3 rectangles that are 2 by 1. So there's 1 rectangle right here, 2 by 1, boom. Right here, these 2 ones. Then it's another one right here, boom. These 2 ones right here. Then it's a third one right here, boom. Boom, with these 2 ones. So there's 3 of those in total. So we add that to our count, boom. Then there is 1 rectangle of side 2 by 2. So that's this square right here. All these 4 ones right here form our 2 by 2 rectangle or square with these 4 ones right here. There's 1 of those, so we can add that to our count. Boom. And then there's also one that's a 3 by 1 rectangle, which is these 3 ones right here. Boom. See these 3 ones? That's our 3 by 1 rectangle. So in total, we have 6 plus 2 plus 3 plus 1 plus 1 equals 13. So our output is 13. Those are all of our submatrices with all ones. Let's take a look at example 2. Example 2 is the same principles, but let's go through it anyway. So in example 2, we have our input mat equals our 2D array of integers 0, 1, 1, 0. 0, 1, 1, 1, and 1, 1, 1, 0, right? Same thing. This represents the top row. This right here represents the middle row. And this right here represents the bottom row. This time the output is 24. There are 8 rectangles with side 1 by 1. So that's just all of the ones as its own square or rectangle. So there's 1, 2, 3, 4, 5, 6, 7, and 8 of those. Boom. Then there are 5 rectangles with a 1 by 2. So there's 1 right here, this rectangle right here. Boom. Then it's these 2 ones right here. Then there's another one right here with these 2 ones. Boom. Then there's one right here with these 2 ones. That's 3. There's one right here with these 2 ones. That's 4. Then there's one right here with these 2 ones, and that's 5. Boom. Then there are 2 rectangles with that's a 1 by 3. So that's 1 right here, 1 right here. So these 3 these 3 ones right here, and these 3 ones right here. Boom. Then there's 1 2 by 1. So that's these right here. There are 4 of these. So there's 1 right here. Boom. Then there's 1 right here. Boom. Then there's 1 right here. Boom, and there's one right here. Boom. Then there's two rectangles of 2 by 2. So there's one right here. Boom, with these right here. And then there's one at the top with these right here. Boom. Then there are two rectangles that are 3 by 1. So that's these 3 ones right here and these 3 ones right here. Boom. Then there's one rectangle that is 3 by 2. So that's this rectangle right here. Boom. So in total, we have 24, and that's why our output is 24. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. First thing we're going to do is we need the number of rows in the matrix. So to get the number of rows, we're just going to say let m equal mat.count. Then to get the number of columns, we need the number of columns as well. So we're going to say let n equal mat square bracket 0 dot count. Boom, and that's going to get us the number of columns. Then we need to keep track of how many consecutive one submatrices can end at the column range J through K for the rows processed so far. So for that, we're going to declare a variable called TMP. And we're going to set that equal to a 2D array of integers. Come outside of those square brackets, open up the parentheses. They're going to be repeating. It's going to be repeating colon. Then it's going to be an array of integers. And that array of integers is going to be repeating colon 0, comma, count, colon, n. Come outside these first parentheses, still inside the other parentheses, and we're going to say count, colon, m. Oh, no, sorry, they're both n. Sorry. Boom. Now we need a place to store our final answer, so we could come underneath this, declare a variable called ans, and we could just set that equal to 0. And this right here is going to keep count right of our output. So that's where we're going to store our output and ans right here. Boom. Now we need to iterate through each row of the matrix. So we're going to say for I in 0 dot dot less than m. Then we're going to open up the brackets. And we need to do the same thing for the column. So we're going to say for j in, sorry, that should be j in dot dot less than n. We're going to open up the brackets. So first we're going to create a variable called fact, and we'll set that equal to 1, and that's going to be used to track if the submatrices J through K are still valid and all ones. Then we're going to extend the submatrices from column J to column A by coming underneath this, and we're going to say for K and J dot dot less than N. We're going to open up the brackets. Boom. Then we're going to multiply the current cell and 0 if any cell is 0, otherwise it stays 1. So we're going to say fact times equals mat square bracket I, come outside of that square bracket K. Boom. Then we're going to come underneath that and we're going to say let cur equal, open up the parentheses, fact plus TMP square bracket J square bracket K times, come outside the square bracket, times fact. Just like that. Then we're going to add the number of submatrices ending at this row segment by saying, coming underneath this, and we're going to say ans plus equals cur. Then we're going to update the DP state for the future rows by coming underneath this and saying TMB square bracket J, come outside of that square bracket K. We're going to set that equal to cur. Then all we have to do is return our final answer by coming right here and saying return ans. And that should be all she wrote, y'all. So let's give it a run. See how it runs first before we submit it. Okay, we have an error. Oh, this should be for 0. dot dot less than n. So let's run it again. Let's see, and it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Now look at that, y'all. 61 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top. This is the rest of it. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.